Okay, let's talk about proportions. So I'm going to go through this example in the book real quick with you. So how much time will it take to install 256 feet of ridge cap if the first 24 are installed in 32 minutes? So first of all, ridge cap, that's just the shingles right here where along the ridges where this region and the region back here meet. Okay, and so it's just a straight line of it. And you have ridge cap there, and you have it there, and you got it there, and you've got it there. Okay, so so that's the idea. Now they say, hey, we know that every 24 feet takes us 32 minutes. So they relate those two guys in a ratio. And so then they say, all right, so the question is, how long is it going to take us to get 256 feet done, okay, of the ridge cap? Well, so we say, well, whatever our answer is, it should make it so that this ratio is equal to this ratio. Okay, and we're assuming that we don't slow down toward the end of the day either. Okay. So if this is our ratio that everything in this problem has to agree with, then this ratio over here, first of all, it has to have the 256 in the bottom, okay? Because in this one, 24 feet is in the bottom. We've got our feet, our distance in the bottom, so we do the same thing over here. On the first fraction, the first ratio, we got time on the top, so we're gonna have time on the top over here. Again, so the two ratios match up. Okay. Once you have a ratio equal to a ratio, then this is called a proportion. That's just the name of it. So in other words, the time and the distance are proportional to each other. So the way to simplify, and they first off, they rewrite it like that, no big deal. And they say, all right, let's cross multiply. 32 times 256, bam. 24 times t, bam, right there. Then they multiply those together, get the 8192. Divide both sides by 24, okay? And then it's approximately equal to 341 minutes, okay? And that's kind of how it goes. And the author, gives you all this stuff over here to help you understand what's going on. And he has some funny little comments there. So anyway, so that is how it's done. Let's take a look at some other stuff. How about problem number 4 in the homework area? All right, so problem number 4. Plumbers use a slope of 1/4 inch per foot to ensure the proper flow in waste pipes. So like under your house or in the sewage line between the houses or whatever, they've got a, oh, whoops, I hit that button again. They have this, the pipe is like this. We don't want it to be horizontal, okay, because then nothing goes anywhere. We don't want it to be vertical, that'd be dumb. But, and so if the pipe is too steep, okay, so maybe it's more like that, then the liquid waste goes away real fast and it doesn't bring the solid waste with it, okay? And so it doesn't work. If it's too shallow, it's like, yeah, there's an angle there, but it's too shallow, it's not steep enough, then stuff doesn't really move, okay? So they figured out, hey, this works pretty good. All right, so that's what everything in this problem needs to agree with, okay? So 1/4 inch, sorry, so 1/4 inch drop or fall for every 1 foot of pipe, okay? So that is what everything has to agree with. Kind of like that 32-minute, 24-foot thing, the last one. Okay, now, we've got a length of pipe right here, 31 foot 3 inches. And since on the first ratio, length of pipe is on the bottom, I'll put length of pipe on the bottom here. So 31.3. And so we're looking for how much fall do we need? Well, yeah, that's exactly what you would look for. If you were doing this, like, okay, we got to do this correctly. Not too much, not too little, so that it works properly. Okay. Now, we can cross multiply right now, but look what happens. We get inches times feet in inches. Oh, dear. So we got to either convert. Well, I guess, yeah, the main thing is this length is in feet. And so this length needs to be in feet also. Or, well, things just need to agree. What would really be good is if everything was inches. Let's just convert everything to inches. So if we do that, then, there it is. Then I'll just rewrite 1 foot as 12 inches. Okay, cool. So I got inches over inches. And then this guy here, well, that's 31.3. Tell you what, why don't we just go to the calculator? Okay. So 31 feet is going to be 31 times 12 inches. And then we gotta remember to add on that other 3. So 375 inches. All right. So 375 inches. Okay, cool. So now we're ready to, get this show on the road. So we get 1/4 times 375 equals 12 times question. Times what we're looking for. Okay. Well, this is really just 375 divided by 4. So I'm going to let the calculator do my dirty work for me. 93 3/4. Okay. So that's 93 3/4 inches. Now it's time to divide both sides by 12. Okay. And so I'll take this guy, divide by 12, and I get 7.8125 inches. Now let's see, what does it say? How do I want to round this up? Blah, 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 blah. It doesn't say how to round it off. Let's go feet and inches and the nearest 16th of an inch, just for practice. Okay, so we got 7.8125 inches. Well, I guess we don't need feet then. So yeah, the fall is only almost 8 inches. Okay, so I know I've got 7 complete inches, and then let's go 16ths of an inch. I will get rid of that 7 complete inches. I've already accounted for that, and I'm left with 0.8125 inches. And if I want to convert that to 16ths of an inch, I multiply by 16. And whoops, that is not what I meant to do. Okay. Multiply by 16. And I get 13. Wow, exactly. That's rare. Okay. So that would be 13/16 of an inch. They didn't ask me to do this part here, but I thought it'd be good practice for us. So that is how far it has to drop from the start to the stop of that 31 1/4 foot pipe. All right, now let's take a look at number 8, and I'll talk about urine samples, everybody's favorite. So a 20 milliliter portion of a urine sample contains 1.2 milligrams of a drug. Aha! So every 20 milliliters of urine has 1.2 milligrams of some drug. So that is our ratio that everything has to agree with in this problem. So find the number of milligrams. Oh, so we're looking for milligrams. Milligrams on the bottom, so what I'm looking for is in the bottom. If we do 170 milliliters of urine, okay? Now, this guy here is like about 8 times bigger than this. So I would expect this guy to be about 8 times bigger than that. 8 times bigger is 9.6. Okay, so it should be close to that. It's actually gonna be a little more. I'm gonna guess 10.2. but pretend I didn't say that. Okay, so now I can cross multiply. So Shazam, I get 20 questions. Boom, ba-doom, 1.2 times 170. And then I'm going to divide both sides by 20. Now, wait for it. Go to my calculator. You didn't see that coming, did you? Said Wanda's brother just before he died. Okay. So I got all that, and then I'm going to divide that up by 20. Whoa, look at that. The old man still got it. Okay, so 10.2, whatever it's called. Oh, what were we looking for? Oh, we were looking for milligrams. Okay. So that's going to be 10.2 milligrams of this drug. Okay, yeah, that's pretty close to 9.6. So as you do these, it's good to think about, all right, what's reasonable here? What should I expect, roughly? And then if you don't get close to that, then maybe you guessed badly, or maybe your math is off. So it's a nice check to have. All right, let's take a look at number 14. Whoops, that is way too far. All right, now here's one I'll bet you can do even if I don't teach you how to do algebra. Okay. Car gets 32 miles per gallon. Aha. So it's 32 miles for every 1 gallon. Okay, and per, it gives me that divide sign. Anytime you hear the word per, you're talking division. Okay, anywhere in life. Okay, so find the number of gallons. Oh, okay, so we're looking for gallons. Gallons are on the bottom, so I'm looking for the thing on the bottom. Required to travel 857 miles. So my miles are on top. Cool. So I cross multiply and I get 32 question. And then 1 times 857, divide both sides by 32. And I don't know. I'm going to find out. Let's clear that up. Okay, so 857 over 32 is 26.78. Let's see, what does it sit around it off to? 1 decimal place. Okay, so that's going to be 26.8 gallons of gas. That's how much gas we're going to need. And that's it.